Hi friends, today we learn about important topic of chemistry, that is photochemical reaction. In last lecture also we discuss about basic principles of photochemistry and certain important terms which are used in photochemistry. So today we learn about photochemical reaction. Also, don't miss to like and share the video. Subscribe the channel Chemistry Online by Dr. Darshan Jani and share this video maximum so every MS student can get the benefit of such important videos. Hit the bell icon to get a regular notification. So let we start our today's topic, that is photochemical reaction, right? So when photocycloaddition of ketone is carried out to carbon-carbon double bond, that is alkene, and carbon-carbon triple bond, that is alkyne, then such reaction is known as Paterno-Bucci reaction. Now in detail when we discuss about Paterno-Bucci reaction, so as we can see here that when ketone in its triplet N2 pi star state added to the either alkene or diene via cycloaddition reaction, then what will happen? It will give oxygen as a product via intermediacy of either diradical or biradical. Let me explain this statement with appropriate example. So as we can see here, when this diphenyl ketone will undergo reaction with H mu photon, then first of all it will be converted into diradical or biradical as we have discussed. Then when such diradical is reacted with acrylonitrile, then it may give such type of intermediate which will finally gives or converted into oxygen, as we can see here that 4-member ring with oxygen is known as oxygen, as we can see here. Now friends, in triplet N2 pi star state of ketone and triplet pi 2 pi star state of alkene, when having comparable energy, then it may undergo energy transfer or ET process, as we have earlier discussed in our earlier video lecture, right? So such ET process in detail we have already discussed. Here we can explain the example of ET process. As we can see here, when diphenyl ketone in its triplet state N2 pi star state in diradical form, it react with, that is donor acceptor process, as we have earlier discussed. So in ground state it will react with alkene, so finally we will get triplet pi 2 pi star state of alkene and diphenyl ketone in its ground state, right? So excess of energy of ketone is transferred to the alkene in its triplet pi 2 pi star state from triplet N2 pi star state of ketone, as we can see here. Again, when ketone in its triplet N2 pi star state undergo cycloaddition with carbon-carbon triple bond, that is alkyne, what will happen? It will give unstable oxytenes as a product, and it will isomerize, or we can also say that rearrange to give alpha beta unsaturated ketone as a product. How? Let's see with the example. When diphenyl ketone react with H mu photon, first of all what will happen? It will give triplet N2 pi star state with diradical intermediacy. Then it will give 4-member ring with double bond or unsaturation, which is known as oxytene, and as we have discussed, it is unstable, so it will be converted or isomerized to alpha beta unsaturated ketone as a product. So friends, as we have discussed, photocycloaddition of carbonyl compound to either alkene or alkyne is known as Paterno-Bucci reaction. Now the next important photochemical reaction, that is Norris type 1 and Norris type 2 reaction. So it is a photolysis of carbonyl compound. So how it is carried out? Let's see with example. So as we have discussed that when carbonyl compound is applied to irradiation, or we can also say that when we gives irradiation to carbonyl compound, then it will undergo carbon-carbon bond cleavage, right, as we can see here, and it will gives a number of product, right. So when this carbon-carbon single bond cleavage alpha to carbonyl group is carried out, then this cleavage is known as either alpha cleavage or Norris type 1 reaction. As we can see here, it will take place in a triplet N2 pi star state of ketone. And why this cleavage alpha to carbonyl is carried out? So it can be seen here from this figure that when half vacant non-bonding molecular orbital, that is NBMO, half vacant NBMO of triplet N2 pi star state overlap with sigma bonding molecular orbital, sigma BMO of CC bond, then this overlapping process will facilitate the cleavage or alpha cleavage to carbonyl compound. Now we have or a question arises in our mind that in case of unsymmetrical ketone, what will carried out? So there is one example. When there is a case of an unsymmetrical ketone, then in such case the overlap will take place in direction in which more stable either acyl or alkyl radical are formed, right. So it can be easily explained with the help of this example. So here this unsymmetrical ketone, when there are two possibilities, or we can also say that two alpha CC bonds are there. One is here and the next one is here. So which will undergo cleavage, right? So as we can see here, this is not possible. Why? So it will not gives the stable acyl or alkyl radical, while in this case when we apply irradiation to unsymmetrical ketone, what will happen? It will gives, as we have discussed, more stable alkyl and acyl radical. So this will gives cleavage of this particular bond, as we can see here, to gives diradical, and this cleavage is known as either alpha cleavage or Norris type 1 reaction. So friends, after discussing the chemistry or photolysis of asymmetrical ketone, let me discuss about photolysis of acyclic ketone. As we can see here, in case of acyclic ketone, when we irradiate the molecule, what will happen? It will gives two radical intermediates. So these two radical intermediates may take part in a secondary reaction which is dependent on the reaction condition to give different product. So let me explain this thing with example. As we can see here that when diphenyl ketone undergo or irradiate with H mu photon, then in triplet N2 pi star state it will give the biradical, as we have discussed. Now at room temperature it will give two radical intermediate such as phenyl radical and benzoyl radical, as we can see here. Now when we carried out reaction at room temperature, then it will give either benzyl or biphenyl as a product. But if we carried out heating at greater than 100 degrees centigrade, then this benzoyl radical undergo decarbonylation and we will get biphenyl as a product. So it is basically dependent on a reaction condition. Now third possibility, that in case of cyclic ketone, what will happen? This diradical may decarbonylate and resulting diradical may cyclize to give strainless ring, or we can also say that contraction of ring may take place, as we can see here in example of cyclohexanone. So when we irradiate the molecule, what will happen? It will give triplet N2 pi star state with biradical. Now this diradical may undergo decarbonylation and it may give cyclopentane as a product. So we can easily say that this 6-member cyclohexanone ring, after decarbonylation, it will give strainless 5-member ring, right? So by this way we can easily discuss the example of either asymmetric ketone, then acyclic ketone, and again cyclic ketones, right? And all these are the example which are considering Norris type 1 reaction, that is alpha cleavage to carbonyl group. So friends, there is one more condition in alpha cleavage to carbonyl, that is in photolysis. Let's see, if there is a presence of delta hydrogen atom to carbonyl compound, then what will happen? As we see in last example, that diradical which are formed due to photo irradiation or photo excitation, this diradical may undergo abstract proton from delta position, as we can see here. Then what will happen? It will give unsaturated aldehyde as a product. So there is one more condition, when there is a presence of delta hydrogen in compound, then the diradical which are formed in primary reaction may abstract proton from delta hydrogen to give alpha beta unsaturated aldehyde as a product. Then next one is, as we can see here on the board, that in acyclic ketone, if there is a presence of hydrogen at gamma position, then the diradical which are formed by primary reaction may abstract proton from gamma position and it will undergo beta cleavage, or which is also known as Norris type 2 reaction. Let's see with the help of example. As we can see here, the acyclic ketone having proton at gamma position. So when we carried out irradiation of such acyclic ketone in presence of H mu photon, then it will give, here we can write H mu photon. So what will happen? It will be converted into triplet N2 pi star state, that is diradical. Now we can see here in the example that the next position to carbonyl is alpha, beta and gamma. As we have discussed, if there is a presence of proton at gamma position, then what will happen? It will abstract proton converted into OH. Now there is one radical here, it will undergo alpha beta cleavage, right? So this beta bond will cleave to give these two product, that is CH2 double bond CME, and this one which will enolize to give ketone as a product. So by this example, when there is a presence of gamma proton, then it will undergo Norris type 2 reaction, that is beta cleavage. There is one more example. As there is the presence of alkyl or aryl group at gamma carbon, then what will happen? Then it will cyclize, or diradical which is produced by primary reaction may cyclize or compete with beta cleavage to give cyclic product. How? Let's see with the help of example here. When this reactant or substrate, or we can also say that ketone having alkyl or phenyl group at alpha, beta, gamma position. So when we irradiate such molecule with photon, it will be converted into diradical in triplet into pi star state. Now same thing will be repeated here. As we can see here, it will abstract proton from this gamma position. Now the diradical which is generated may compete with beta cleavage to give cyclization, and we will get cyclobutanol derivative as a product, as we can easily see here. So friends, by this way we can easily memorize either it is a photocycloaddition of ketone, that is a Paterno-Bucci reaction, or photolysis of ketone, whether it is alpha cleavage, that is Norris type 1, and beta cleavage, that is Norris type 2 reaction. So by this way we can easily memorize important photochemical reaction. Also friends, don't miss to like and share the video, subscribe the channel Chemistry Online by Dr. Darshan Jani, and hit the bell icon to get a regular notification for such important videos. Thank you very much.